Hey, welcome. Today, we're going to build something that sounds like science fiction, a crystal ball for machines. We're going to take raw, messy data and turn it into a powerful tool for seeing the future, all using a simple AI blueprint. Let's dive right in.
Just think about that for a second. Seriously, what if, instead of a sudden catastrophic failure, a critical piece of machinery could just kind of raise its hand and say, hey, I'm not feeling so great. You might want to check on me. What would that really change?
Well, for manufacturers, this is not just some cool what-if scenario. It's a massive, multi-billion-dollar problem. Unplanned downtime, it brings everything to a grinding halt, it delays orders, and it just sends costs through the roof. So solving this, it's not just important, it's an absolute game changer.
So, let's really set the scene for our AI challenge here. We'll call this first part the costly breakdown.
I want you to picture it. You've got the low hum of a busy factory floor. Everything's running like clockwork. And then, without any warning, one single critical machine just stops. A gear seizes up, a motor burns out, and suddenly there's silence. Just like that, an entire production line is completely dead in the water. But what if that machine has been keeping a secret diary, a digital one to be exact? And that brings us to our next section, where we're going to look at the raw ingredients for our AI recipe.
Okay, at first glance, I know what you're thinking. This looks like a really boring spreadsheet. But this is the machine's diary. Every single row is a little snapshot in time, a log of its vital signs. And the most important part? It's that row right there. See that one under machine failure? That's our target. That's the exact moment things went wrong.
So what are these vital signs we're looking at? Well, first up is torque. Now, it's measured in Newton meters, but don't worry about that. You can just think of it as the machine's effort level. Is it just coasting along, or is it really straining to get the job done?
Next up, we have tool wear. This one's pretty straightforward. It's kind of like the tread on your car's tires. The bigger the number, the more worn out the tool is. And probably, the closer it is to needing a replacement. Simple.
And finally, we get to the most important piece of data for this whole project: machine failure. It is just a simple flag. A 0 means, hey, everything's cool. But a 1 is our digital smoke signal. It's the exact event we want to predict. Okay, so we have our problem and we have our ingredients. Now, it's time for the recipe itself. This is our super simple 4-step AI blueprint for turning all that data into actual foresight. And really, it's simpler than you might think. Step 1, define your goal. For us, it's to predict machine failure before it happens. Step 2, gather the data. That's our digital diary. Step 3, train the model. This is the magic part, where the AI learns to find hidden patterns. And finally, step 4, make a prediction. We turn all that learning into a real-world alert system.
So let's zoom in on that magic part, training the model. How do we actually teach a machine to spot the warning signs? How do we teach it to, well, see the future?
The AI does this by looking at thousands, even millions of these moments. But for now, let's just focus on these two, right here. The top row, that's a normal operation. The bottom row, the one that's highlighted, that's the exact moment a failure happened. Can you see the difference?
When we put them side by side like this, the pattern just jumps out at you, doesn't it? During normal operation, the torque was chugging along at 32.4. But right before the failure, bam, it spiked to 65.7, more than double. And the tool wear ticked up too. This right here is the telltale sign, the subtle signature the AI is built to find.
You can almost imagine the AI thinking to itself while it's training, right? It's going, aha, I see. A big jump in torque, especially when the tool wear is already high, that's a red flag. Got it. I'm going to file that pattern away. It's literally just a pattern recognition machine on steroids.
And here's the amazing part. It doesn't just do this for 1 or 2 failures. It sifts through thousands, millions of data points, both the good times and the bad. It learns every tiny little nuance, every combination of factors that creates the unique fingerprint of a breakdown. It sees things a human could never, ever spot.
So after all that learning, all that pattern finding, what do we actually end up with? We get our crystal ball. This is the final amazing step where data officially becomes foresight.
And the final product isn't some super complex chart or a dense report. It's simple, it's powerful, it's an alert.
When the live data streaming from the machine starts to look like a known failure pattern, an alarm goes off, telling an operator, hey, machine 7 needs your attention sometime in the next 24 hours.
And this simple alert changes everything. We go from reactive repairs, fixing things after they break, to proactive maintenance. We go from that expensive, chaotic downtime to cheap, scheduled service. We completely replace guesswork with sharp, data-driven decisions. It's a total paradigm shift. And just how effective is this? Get this, a well-trained model using exactly this kind of data can hit an accuracy of over 98%. Think about that. That means it can correctly predict a failure or a normal operation 98 times out of 100. That is foresight you can actually rely on.
And what gets really exciting is that this isn't just about manufacturing. This whole blueprint, finding patterns in data to predict an outcome, it can be used almost anywhere. Which leaves us with one last, really big question. If we can teach an AI to see the future for our machines, what else could we use it for? Where else can we point this powerful new crystal ball?